Hello, welcome to the homework helper for the first lesson of Unit 2 for the Ready, Set, Go problems in your textbook. We're going to dive right in with number 3. Number 3 and number 4 are very similar problems. Number 3 asks us to identify the vertex, the axis or line of symmetry, and indicate whether or not the vertex is at a minimum or maximum for the graph. So we have a parabola that's opening up, which means that the vertex is here down at the bottom, which also means that it's going to be a minimum for the graph. But the coordinates of the vertex are going to be x is equal to -1, y equals -2. And the axis or line of symmetry we can get by drawing a vertical line directly through the vertex. So the equation of the line of symmetry is always going to be x equals whatever the coordinate is, the x coordinate is for your vertex. So in this case, it's going to be x equals -1. And then since this is a parabola that is opening up, we are going to be dealing with a minimum value for the vertex. Number 4, once again, very similar. Here we have a parabola that's opening down. So in this case, the vertex is at the peak. The coordinates of the vertex are at -3, 5. The axis of symmetry, once again, is a vertical line straight through the vertex. It is going to be at x equals -3. And then, since, as I mentioned, this is opening down, we're dealing with a maximum. Number 7, we've already kind of answered this question indirectly through numbers 3 and number 4, but what connection exists between the coordinates of the vertex and the equation of the axis of symmetry? So if we have a vertex at HK, then the axis of symmetry is going to be at x equals h in this case. So the x coordinate is the same. Number 8 is a little bit different than what we've been talking about, but still involves the axis of symmetry. Here we're taking a look at the x-intercepts and determining if we could find the line of symmetry. All right, so in this case, looking at this parabola, the axis of symmetry is a little bit tough to find, but we can actually do this by taking the x-intercepts and discovering that the axis of symmetry is actually halfway in between those. So we have the x-intercepts in this case are at -6 and +3. And if we were to take the average of those two, we'd be able to find the axis of symmetry. So the axis of symmetry we're going to take the average of those two. So that's going to give us -1.5 or -3/2. So the axis of symmetry is actually right about here, give or take. So the axis of symmetry, you can say, is halfway between x-intercepts. Moving on to problem number 10. This is the last question in the ready portion of the assignment. All we're tasked with doing here is sketching a parabola that has no x-intercepts and what would cause it to have no x-intercepts. In order to do this, we either need a parabola with a vertex above the x-axis that opens up, so something like this. call this example 1. Or we can have a parabola with a vertex below the x-axis. Let's say it's like right around, right around here, below the x-axis, and have it open down. So there are infinitely many parabolas that exist that don't have any x-intercepts, but those are the qualifications that we need in order for that to happen. So there's lots of different ways that we could do this, but typically you're looking for a parabola with a vertex above the x-axis that opens up, or below the x-axis that opens down. All right, we're going to press forward to number 12, which is the first problem in our set portion of the assignment. And here we are going to be given a table and tasked with generating an equation for g of x and sketching its graph and describing what changes are made from f of x to g of x. So if we look at the table for x and f of x, we can identify f of x, and if you can't identify f of x, it's actually given to us a little bit later, as x squared. Right, so from -3 to get 9, we just square it. To get from g of x, though, we go from -3, 11, -2, 6. All right, so essentially what we're doing is we're adding 2 onto 9 to get 11, adding 2 onto 4 to get 6, 2 onto 1 to get 3. So this is going to be whatever we did for f of x, so x squared, plus 2. So that's going to be the equation of the function for g of x. And I'll write it in here for part A. Now, to sketch this graph, typically the easiest way to sketch a parabola or a translation of a parabola is just to grab the vertex and shift that and then sketch the parabola around it. So here we need to take the vertex that is normally at the origin and shift it up 2. And when we sketch this out, it should look something like this. This isn't perfect, but every point also gets shifted up 2. So that's pretty much our response to part C, is all points are shifted up 2. Number 14 is similar to number 12, but perhaps a bit trickier to see. Once again, we're given a table with f of x and g of x, and we have to determine what the function for g of x is. I think this one's a little bit more challenging. We got f of x is, again, going to be x squared. This is a little bit trickier to see. We do have a bunch of perfect squares in the g of x column, so perhaps it's not that much of a stretch to find it. So 36 is the same as -6 squared. So in order to get this, we're going to need to shift everything to the right 3. So writing this out, g of x is going to be the quantity of x minus 3 squared. All right, just to show you how this works, if I were to take the first coordinate here, -3, -36, and I were to plug it in to this equation, g of -3, we get -3 minus 3 squared, which is -6 squared, which is the 36. And I'm not going to do it, but you could see that each one of these values would work out for this equation. So the function g of x is x minus 3 squared. And in order to sketch this, this is one of the ones that's a little bit tricky, is that every value is going to be shifted to the right 3. So minus 3 shifts it to the right 3. So this point right here, the vertex moves from 0, 0. And I'm just going to kind of sketch this. it'll look something like this. So there's our g of x right here. And as was the case with number 12, how does the graph different? All the values are shifted, in this case, to the right 3. We're going to be moving on to the final section of this first homework assignment. These are the Go problems. Here we're going to have to graph lines, which is a little bit different because we were working with parabolas for the first part of this. Number 15 is a line in slope-intercept form. So you may be familiar with seeing this in the format of y equals mx plus b. So here, in this case, b is the y-intercept, so the y-intercept is equal to 7, and the slope is the m is equal to negative 2. All right, so when we are given an equation in slope-intercept, easiest way to go about it is to plot the y-intercept and then use the slope to generate the rest of the equation. So let's head down to the graph here, and I'm going to just sketch in the axes, x's and y's. We get our y-intercept is at 0, 7, 1, 2. I believe that's 7. And now we're going to use our slope to generate the rest of the line. And once we've done that, we can connect the dots and generate our line. So the slope is negative 2, so I'm going to go down 2 to the right 1, down 2 to the right 1. We could also go up 2 to the left 1, and that would also work. But here is our line. It should look something like that. Now, I didn't go into detail in determining exactly where the x-intercept is, so this is just a sketch. You can find out where the x-intercept is, but it's not specifically asked for in this problem. So the y-intercept was given. The x-intercept we could solve for. I believe the x-intercept would be, let's see here, like negative or 3.5. So it's a little bit off. Should be closer to right here. Number 17. This is a problem that's given in standard form. ax plus by equals c. In this case, the easiest way to go about doing this is to find the x-intercept, the y-intercept, and then plot the points. So start with the y-intercept. We get this by setting x equal to 0. So that ends up being 0. So we get 5y equals 30. Divide both sides by 5. Y is equal to 6. So the y-intercept is at 0, 6. The x-intercept, similar process. Now we're going to set y equal to 0. So this ends up canceling out. We get 3x equals 30. We get x equals 10. So the x-coordinate is at 10, 0. All right, so sketch in the axes here. I'm going to give myself a little bit of space. So we get 0, 6, 1, 2, 3, 4, 5, 6, right around there. 10. Right around there. And now once we have these 2 points, we just kind of connect the dots. Oh, that's so far off. Apologies. There we go. That's better. All right, the last problem for the problem set is an equation of a line, and this one's given in point-slope form. And this one perhaps looks intimidating. I'm going to rewrite this equation and change f of x to y. So we're going to set it to y minus 8 is equal to negative 1/2 x plus 9. So here the point that we're given is going to be at negative 9, 8. And now we can use this point, and then the slope, which is m, is equal to negative 1/2. So once again, we're given a point, and we're going to use that point and then just work the slope to find other points. So plotting this point, let's see, we want to make sure that it fits here. So negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to say it's about there. And once we have that point, we're going to just use our slope of negative 1/2 to generate a couple other points. So we can go down 1 to the right 2, down 1 to the right 2, or we could go up 1 to the left 2 to get our other point. And this graph is going to look something like this. So once again, notice that I didn't spend a whole lot of time, or any time really, trying to identify where the x and y intercepts were, because they're not targeted in this part of the problem. We're just sketching the line. So this has been the first installment for Unit 2. Hopefully this was helpful for you. I'll see you again for Lesson 2.